Hi, I'm Atul and I am based in London right now.
Hi, I'm Paul and I'm an A-Level Chemistry tutor based in Burnley, Lancashire right now. Today we're going to have a look at an electrochemical series question, and it says write an equation for the reaction that would take place if zinc and nickel half cells were connected together. So we're going to use the electrode potentials we've been given for zinc and nickel. And if we look, the electrode potential for the zinc half cell is minus 0.76 volts, and the electrode potential for the nickel half cell is minus 0.25 volts. So how I like to work this out is the more negative potential is the one that's producing the negative electrons. So it makes to me more sense that the one that's producing the electrons, which are negative, will have the more negative potential. So I need to write this equation the other way around so that it's producing electrons. So we have zinc providing zinc ions and electrons, and that electrode potential is 0.76 volts. And the nickel one stays as it is, because if one half cell is producing electrons, the other half cell will be accepting electrons. So we have nickel accepting electrons and turning into nickel metal, and the electrode potential for that is minus 0.25 volts. So to do the overall equation for this reaction, we just combine the two half equations. Now the electrons are balanced, so we don't need to multiply the equations to make the electrons balance. So we can cancel out the electrons and then just write down what we've got on the left and right hand side of the equation. So nickel and zinc will give us Zn 2 plus and nickel. And if we wanted to work out the electrode potential for the full cell, then the EMF of this will be the more positive potential, which is the minus 0.25 volts. Take away the more negative potential, which is minus 0.76 volts. And then we just put that into our calculator, minus 0.25. Minus a minus is an add, so add 0.76. And that gives us an electrode of 0.51 volts. So the overall cell EMF would be 0.51 volts when these two half cells are put together. And you also might be asked about what's been the reducing agent, what's been the oxidizing agent. Atul, using your chemistry knowledge, could you identify the oxidizing agent and the reducing agent in this reaction?
Yeah. So the oxidation would be the loss of electrons, and the oxidizing agent would therefore be the thing that causes the loss of electrons. So the oxidizing agent is taking up electrons, which is nickel 2 plus ions, yeah.
Yeah,
Yeah,
yeah, that's correct.
taking up the electrons, so that's the oxidizing agent.
Hmm.
Presumably vice versa for the reducing agent. So that's got to be the zinc. Yeah, it's got to be the zinc 2 plus.
Yeah, because that's the providing the electrons. So you can look at this in terms of electron loss, electron gain. You can also look at this in terms of oxidation states. So if you look at the oxidation state of zinc, it's going from 0 to 2 plus. So that's being oxidized. So the oxidizing agent, as you said, must be the nickel 2 plus. And the nickel 2 plus is going from a 2 plus oxidation state to a 0 oxidation state, so it's being reduced, and therefore the reducing agent must be the zinc that's reacting with it. And good job I just checked, because I put Zn2 plus there rather than zinc. Yeah, so from just these two equations from the electrochemical series, we can do the overall equation, we can work out the cell EMF, and we can identify oxidizing and reducing agents.
Got it, yeah. Yeah, that's a lot neater, isn't it? Just to work with the oxidation states rather than, yeah, so the GCSE version is what's causing the oxidizing and oxidation and reduction. Yeah, and presumably, does the order matter where they do the subtraction? What if they ended up with doing this minus that and get a minus 0.51?
Yeah, then that wouldn't be feasible. You need a positive potential for the reaction to be feasible. So it's always got to be the more positive take away the more negative to get the overall cell EMF.
Yeah. That's great. And just putting like my physics hat on, that also just reinforces the idea of that this is actually a difference. It's a potential difference. So there's a difference in potentials, and therefore the overall EMF due to the difference in potentials is that calculation.
Yeah, and it's the difference in potentials that's creating the current, the charge to flow around the circuit.
Yeah. That's fantastic. Ties in very, very well with physics as well. And yeah, there's a difference in potential, therefore there's a flow of electrons around the circuit. So you get the whole electrolysis thing and electricity thing in physics kind of neatly tied up. And essentially, yeah, the how a cell works. Yeah, brilliant. Yeah, that was really good. Yeah, look forward to the next one, whenever that is.
Yeah, I'm sure it'll be next week.
Yeah, great. Look forward to it.
Okay, thanks, Russell.
All right. Thanks. Bye for now.